Welcome to Learning Module W4b. We're going to talk about process, productivity, and efficiency. I like this quote: productivity is never an accident. It is always the result of a commitment to excellence, intelligent planning, and focused effort. Makes a lot of sense to me. We have to pay attention to the details, and we have to put our plans together and stay on it if we want to become productive and improve processes. So in this module, we want to understand productivity and efficiency as concepts, what they are, and how to calculate them. Productivity is an index, and you may recall from other discussions, other modules, that it is if it's an index, it's a relative measure. We'll talk about that a little bit. But productivity itself is a measure of process performance. We find it by dividing outputs over inputs. Always the output on top, the inputs on the bottom. Let's look into that. As I mentioned, it's a relative measure. It has to be compared with something else. So it's not a continuous measure. We can't look at it like we do with pounds, inches, with different the scientific measurements and continuous measurements that we have. It is relative. It means we have to compare it to something for it to take on meaning. So if we're being consistent in the way that we measure something, we can compare it to other companies, other nations, other data that are measured in the same way. So we can benchmark productivity if we're sure that it's being measured consistently across different organizations. We can also track it over time within our own organization. So we can say daily, weekly, monthly, annually, here's a productivity index. And we measure it the same each of those periods, so it's comparable. It takes on meaning because we know when we look at January and we look at February that there's stability in those numbers underneath, building the index. It should be normalized data. The important thing is to be consistent in those measurements so that we don't have movement in the index and attribute that to something when really it's instability in our numbers. We have to make sure. Okay, so we need to know about single factor and multi-factor productivity. So the single factor is basically a productivity score that measures output levels relative to a single input. What's an example of that? You could take any output you like: sales, production volume in a day. You could take various outputs, anyway, it doesn't matter which one, and attribute a single input to that. So let's just take the production one. Let's say we build 1,000 units of something per day. Well, there's various inputs. There's maybe labor, there might be utility costs, there could be factory overheads, there could be raw materials, there could be all sorts of different inputs into that, right? So we can take a single one of those inputs and examine it, isolate it, and examine that single input, like labor, for example, in January versus labor in February compared to our sales volumes as the output. Or we could take them on an annual basis. But it's comparably, we could take multiple factors. So we could try to find enough factors that it really represents the whole plant, all of the major inputs. We could take a lot of them that I listed earlier, like labor and raw materials and energy and so forth. So we can build basically productivity indexes to serve our needs, either to make us comparable to other organizations that maybe we're benchmarking, competitors, other organizations that are excellent in an area, or to see how we're doing against ourselves. And so there's various uses. Let's take a look here at a little sample data. Here's some outputs, 2012 and 2013. We've got output in sales revenue, $4.79 million in 2012 and $5.75 million in 2013. So there's our outputs for 2 different years. And here are 2 different inputs: cost of the salaries of the sales organization for 2 different years, and the cost of advertising for 2 different years. All right, and we can take those, we can build an index, a single multi-factor index here of these salaries into the total sales dollars, or the advertising into the sales dollars, and they would get different values, right? Here's the sales, here's the advertising, both going to the same output. Or we could combine those two, and we could get a more of a total or a multi-factor productivity of 17.36 for sales and advertising. Sales salaries and advertising into over our sales revenue, or revenue over are those other two. And we could do that for a different year, right? So these two items aren't really comparable, so we'd have to be very careful about drawing conclusions of comparing these single factors to each other, because there's a lot of different things going on in those factors, right? We can't just look at that and say, well, $1 of advertising is more productive than $1 of sales. We don't know that, and it'd be very dangerous to reach that conclusion. What we can do here is look from year to year and start to draw some inferences and some conclusions and some meaning into the numbers, and say, well, the productivity of the salaries from 2012 to 2013 seems to be positive, but the productivity of the advertising is more so, a bigger ratio here. And if we combine them both and say our marketing budget for salaries and advertising, let's say in a simplified model, is gone up this much from year to year, right? From 1736 positively to 1949 from one year to the next. We could also look at the average of them. And we could have a moving average, as we've seen we'll do with forecasting when we do forecasting. So let's look at this change in total productivity from 2012 to 2013, because that would be a typical use that a company would have of an internal index that we built that's a multi-factor index. How do we do year to year or month to month? The way to do that is very simple. You take the newer number, 2013, and you subtract the older number from 2012 in this case, and then you divide by the older number, and that equals your percentage change. What would that mean here? It would mean take our newer ratio, productivity ratio of 1949, and subtract the older ratio, 1736, and we would have a difference of 2.13, and then we would take that 2.13 and divide it over the 1736, and we would have a percentage. So this is telling us that we have a 12.2% increase in productivity from 2012 to 2013 for those factors that we were measuring. This was our multi-factor of advertising and salaries. So our advertising and salaries, as represented by the productivity represented by sales, had a 12.2% increase in productivity. Let's look at another example, and I want you to be able to do this when we look at examinations, is make sense of a little simple statement and know what data to extract to get value out of it. So here we have an example of a car wash, and they've serviced 200 customers in an hour. Okay, so there's our output. They've serviced 200 customers in an hour. What are our inputs? The car wash employs 5 washers at $6 per hour. That sounds like $30 to me for an hour's worth of labor. And we use $50 of water and $5 of electricity per hour. So if we add those inputs up, we would have 30 plus 55, $85. So then I'm going to ask you in an examination, for example, I might ask you, which of these makes sense? And you need to run some calculations to find out. If we look here at the outputs of 200 cars, and then we build up those inputs of $30 in wages and $55 in utilities to the $85 of inputs, we can now do our output over input, and we would see we have $2.35 per car as a productivity ratio. Okay? And I would make sure you're comfortable with that you can read into that, think of the formula, pull out the data that you need, And here we go. Outputs over inputs, simple, bang, get it right. So let's look now at efficiency. So efficiency is a measure of process performance, and it is different, very different than productivity. We're looking at the ratio of actual outputs to standard outputs. Okay, so most businesses will set standards around different aspects of process. We could say we need to build 200, we need to wash 200 cars per hour. How many are we actually washing? We could say we have 5 minutes per car to wash a car. How much time does it actually take? It's important to think about if we're measuring outputs in terms of production outputs in units, or if we're talking about dollars and time and so forth spent, because we may see the minimizing of the actual as a positive efficiency if it's dollars or resources, and we may see the actual as a positive if it's a large number, if it's units, right? So think about that and make sure you're comfortable with it, because the formula gets inverted if we change from units over to a resource. And we're for example, if we're supposed to build 100 cars in an hour and we build 110, then we're going to have a positive ratio if we take our outputs over our actual outputs over our standard outputs. If we measured the cost going into those instead, and we said, what is the cost of the labor producing those cars, then we would see that we need to flip it and take the outputs over the dollars to get the standards. That in that way, the standard dollars are going to be reflected properly if we look at the lower cost achieved for the higher production in the reverse of this formula. We'll look at that. And if you run an example, you'll see exactly what I mean. Here's how we can understand it. So let's look here. This time we're using time, all right, as the basis. So here's a company that is calculating its efficiency, and it performs maintenance for some of its customers, and the standard is always 2 hours. So if they can do it faster, that's a good thing. If we took the normal the efficiency calculation of 100% of actual outputs divided by standard outputs, we would say 1.8 divided by 2, and the ratio that would come back for that would be 90%. Well, that doesn't make sense. If we got this done in 1.8 hours and the standard was 2, it means we did a good thing. We were very efficient. So it's not 90%. It's one of those where we have to reverse it and say it is 2 divided by 1.8, and that ratio is 1.11. It's a positive ratio. So let's look at these, and you'll see that when we get to the one goose egg here, which is the second one, where our time was grossly over the standard, we had 83% efficiency. We had poor efficiency, less than 100% efficiency. Okay, so remember that when you're applying efficiency, that you have to think about, is the consumption of this actual to standard good if I'm over, or is it good if I'm under? And use the formula in inverse as needed, as we did here, to get the correct output, which is, this is a very efficient process. We did it in 1.8, we had 2, that's a good thing, not a bad thing. Okay. So cycle time, we need to talk about cycle time again. When we talked about cycle time in a production environment, it was described in a certain way. We had a certain definition that was accurate, where we said if we have a process or a task, and the longest, most inefficient or bottleneck process in a group would dictate the cycle time of a line, the production rate of a line. That changes when we get to processes. So for process, it is the total elapsed time needed to complete the process. Okay, and that's also called throughput time. So it's slightly different definition than the production line cycle time, and you need to be aware of that. The percent value added time is the percentage of total time that's spent on activities that actually provide value. And in that case, percent value added time equals 100% times the value added time divided by the total cycle time of the process. We could look at an example of that. So here is some theme park, and we've got the Magic Mushroom Ride, and we've got the Haunted Roller Coaster. We've got some average waiting time in the lines. We've got the length of the actual ride itself, which would be value added time, of course. And we've got the total process time. Okay, so how do we calculate that? We basically say we have 10% or 10 minutes of ride time over 40 minutes of total time, or 20 times 100, so that we get 100%. It would turn it into a percentage, which is 25%. Down here we had no waiting time, and we had a 5-minute ride, which took a total of 5 minutes, so we have 100% value added time. All right, we could combine those if we wanted and basically say, well, we had 30 minutes total for the 2 rides in waiting in line, and 15 minutes of total value added ride time, total process time of 45 minutes, and we can do the equation again of 15 divided by 45 times 100% is 33.33%. So the concept is basically saying when we have a process that we want to make sure our time is a high ratio, a high percentage of value-added time, and minimize this wasted time. Unfortunately, there's not a lot we can do at some of these theme parks about that, except stay away from the magical mushroom and the better rides. It doesn't sound like a very good solution. But in business process, we have lots of ways to improve that ratio. In summary, process productivity is a ratio of outputs over inputs, and it is a relative measure. Remember that. It takes on meaning through being able to be compared over time or to other benchmarked, comparably built ratios. Productivity is compared for different periods of time or similar firms or processes. Right? We can benchmark ourselves and not benchmark, but compare period to period, or we can compare period to period with others that have built the same way as standards, and we can benchmark as long as we're sure that the numbers are built comparably, that we got stable data coming in. Efficiency is expressed as a percentage of actual outputs divided by standard outputs. So for most processes, we have standards, and we can measure against them. It's important to remember and look at your efficiency numbers, because sometimes we'll find we're taking inputs that we're happy to have minimized, and that the productivity needs to be inverse the standard versus the actual, so that we get the right read out the back. And we did an example of that, so you understand that, for example, if we do something in a lower period of time than the standard, that's actually a positive impact on efficiency. For process, cycle time is the total elapsed time needed to complete a business process. So be sure to recognize that and remember that. It's used in a variety of ways, and it's not consistent. You can Google this stuff and find different definitions and the way people use some of these terms in operations, and that's just the reality of it. But this is the way we're going to measure it and define it for our text and for our lesson. The percentage value added time is simply the percent of total process time that produces value. All right, so we use the theme park example, but we could also look at any process and say, where are we building value and doing work that matters here, and where are we just spending time in a queue or doing processes that were not necessary, or maybe partly not necessary, or wastefully constructed. Right, so value added time is a very important ratio, or number, percentage rather, in this whole concept. That concludes our discussion on the topic, and I hope you enjoyed it.